So if you don't have any questions, then I'll go with my problems, with my plan, kind of. If you have questions, I can answer some.
All three. Okay. I think you could probably run to the office. And you can take care of yourself. Awesome. You're in charge. You two are in charge. I was going to say. Okay, ask me a question.
All right. No questions, guys. Minute.
Stephanie, any questions? They're speechless.
I know. I see like you're trying to translate what I'm saying to them.
We understand.
Well, maybe sometimes, but not all the time.
It's true.
All right. Well, and since you're not sure, so let's just get to some extra problems, and I'm gonna look at some that I have here with a review. So we'll look at some of those. So I'm gonna start with volumes, kind of that's what we had fresh. And then we'll see what else we have to do. I don't know if I need the screen here, but just in case. And this come on. Alright, so let's start with the volumes. So we'll go with number one, just keep them in order. Have y equals fourth root of x. Y equals 1, x equals 0, and we'll rotate this about x equals -1. So you can get your calculator, for example, just to see how that's going to look like, or if you know, that's great. So, not everything I can graph here, okay? Not everything, but let's see what we have. So, fourth root of x, so it will be x2, 1/4. The next thing, what I have, well, I have y equals 1. Well, that's just the line, so we'll get a 1. And then I have x equals 0, so I'm not going to graph that one. We know that x equals 0 is what? Y-axis. That's y-axis, right? So we have to translate that into kind of a little equation, and we know exactly what to put. Well, this is what I have. So here's my fourth root of x, and there's a line, obvious too small. So let's do zoom 2 and see what we get here. So it's a little bit better. So now we really have to pick up the right area, and that's the one right here, enclosed by fourth root of x, y equals 1, and x equals 0. So this kind of triangle-ish piece, that's what we have. And so something like this. This is what we have. And we have to rotate this about x equals -1. So picture will look something like this. Doesn't have to be precise exactly, right? But it gives us some idea. All right, so this is what we have. And don't forget where your axis of rotation is, and don't forget where your y-axis, just to make sure you know exactly what we have. This one is our original picture. So we're going to do this problem in two ways. We'll use washer, and then we'll use shell method. So which one do you want to go first?
Shell, sure.
So what do? Washer?
Washer first.
Okay. So if we go with washer, all right, remember I told you that's what you have to do on the exam. You have to tell me the method. And then the next thing we have to determine if it's dx or dy. What do you think?
This is
dy.
Now remember, this is simple question, but very important question. So washer, right? The axis of rotation is parallel to what? Y-axis. So for washer, it means what? dd y. Right? I hope you're not confused right now. 100%. Okay, so we have dy. Now, if we have dy, that means what? My function must be changed to what? X equals, right? So, excuse me, we're going to do this right now. So x equals to what?
Y to the fourth.
Y to the fourth, right? So we're going to use this function. All right, so what do I need? I need my a of y function. Don't forget a of y because it's dy, right? And this function again represents the area of the cross section. So my cross section, if I do this over here, and if I do this as kind of rotational piece, I will have I'll have a washer. Now you don't have to do this on the picture. I'm just trying to explain this again to make sure you have no questions here. So this is what I have. And again, one more time, in order to find area of this washer, I need to find area of the larger circle minus area of the smaller, right? So the question is, if I'm looking for the area of the largest circle, I need the radius. And radius always goes from the axis of rotation to the original picture. So the question is, what's the distance from here to right here? 1. So 1, right?
1.
And plus what? Y to the 4. And then what? Square, right? R squared, pi r squared. So that's the area for the larger one. Then minus pi, and distance from here to right here for the smaller circle. And this will be just 1, right? So 1 squared if you want. So as I told you before, when we get to this point, we should be confident that everything works fine because the rest of it is just simple integral. So this is what we have, and then we will put this into the integral. But before we do this, are you okay with this function? Do you understand how to get radius? That's an important piece, okay? We cannot just pick something. But this is what we have. So the next, go the volume, factoring out pi, well, pulling it outside, let's say, integral, and then I have 1 plus y to the 4th squared minus 1, because 1 squared is 1, right? dy. And the next question, from what to what?
Would it be 0 to 1?
No, again, not because we like it, right? But since this is dy, so the question right here, this one is 0, right? And the question, what is over here? And this will be what? 1. Okay, so from 0 to 1, again, this is dy, we're looking at y-axis. So from 0 to 1. So again, look at the function, very simple one. We just have to open parentheses. So we have 1 plus 2y to the 4th plus y to the 8th. Please do not forget, we're not distributing power. We're actually writing it twice. And then FOIL if you like. Minus 1. And as we will take care of the like terms, we have 2y to the 4th plus y to the 8th and dy. So that's what we have for that integral. All right, so now we're ready for antiderivative. So we have here 2y to the 5th over 5 plus y to the 9th over 9 from 0 to 1. So pi, substitution of 1, so 2 over 5 plus 1 over 9. If you substitute 0, you'll get 0. So as the result, we have,
It's minus 190.
what do you mean?
That would be pi times LB.
Just one extra step, right? So we get 20.
3 over 45.
All right. So this is the answer. Okay? Now, and you have to understand, we can look at the process, and the process is not that difficult overall, but you have to get it right. Because if your radius is wrong, then even the work after it is still right. It kind of doesn't make sense then, really, like, so what? It's like, you're designing a bridge, and you have some idea in your mind, and you made a mistake somewhere, and after that mistake, you do everything right. As the end result, bridge will collapse, right? Do you understand what I'm saying? Because you may say, like, I have the right work. Well, the right work with what? With the wrong setup, right? So we have to be careful with this. So that's wash. Now let's do exactly the same problem with the shell method. So with the shell, is it dx or dy? This will be dx, opposite. So putting the picture, so we still have the same picture. So get this piece. And then we have x equals -1 as our axis of rotation. So again, I'm going to put this right here. Alright, so when we go with the shell, remember we have to put a little rectangle inside, which represents the piece of the shell before you rotate. And every time when we put that piece, that rectangle, it must be what? If you put it, how do I put it in? Share the good news. What do we do? How do I put the picture? Remember shell method, I need a little rectangle. How do I put it?
You put it
Horizontally through to the vertical.
So basically what? Parallel to the axis of rotation with the original picture. So my rectangle will be over here. So I have this rectangle, little piece, and I'll put the ax here. Now remember, what is ax? It's the distance from the origin, right, to the rectangle. And this rectangle, remember we said this, you put a lot of those pipes inside, so this rectangle will be moving here, but the distance again to this rectangle is x. So, well, that's basically all I need. If you go to the volume now, we have integral 2 pi and then radius. Now, again, I told you, the formula says 2 pi x, but 2 pi x times f of x dx. But don't forget, it's a very limited representation overall. It's just the idea, put it through the formula. But overall, it's got 2 pi radius, right? So the question is, what is the radius for this shell?
1 plus x.
1 plus x? So again, how do we determine the radius? From the axis of rotation to this rectangle. And this will be 1. Again, one more time, 1 plus x. So we have 1 plus x, good. So careful with this. And the next question, f of x, right? But f of x is what? It's the height of the rectangle. So can you tell me the height of the rectangle? That's the next important question. So what's the height for the
1
rectangle?
minus 4th root of x.
So 1, right? 1 minus 4th root of x. And that's the setup that we have. And of course, from what to what? And I need this on x-axis, right? So the question, what is here, is what? It will be 1 again. And again, not because I like to have 1, it's just because we have 1. So, To continue with this, from 0 to 1, 2 pi goes outside. Integral from 0 to 1. We're going to open parentheses here. So it's 1 minus x to 1 over 4 plus x minus x to 1. X times x to 1/4. That gives it what? It's 5/4 dx. Well, there's no like terms to put together, so we're just going to continue with this. So 2 pi, going with antiderivative, so we have x minus, here we have 4x to 5 over 4, whole thing over 5, right? Plus x squared over 2 minus, we add 1, so we get what, 9 over 4, right? So this will be 4x to 9 over 4 and over 9, and from 0 to 1. Well, let's plug this whole thing in. So we get 1 minus 4 over 5 plus 1 over 2 minus 4 over 9 minus 0 again. And when we do this, we'll have what? 23 pi over 45. So we have the same number. So overall, specifically speaking about this example, it really doesn't make any difference kind of which one's easier, which one's not. But overall, it seems like shell a little bit more convenient, because if you go back and look at the washer method, then we have to find those radiuses, right? That can be a little bit complicated, maybe. But I'm not saying which one's better, which one's not. They have good things and bad things overall. But you have to make a decision. And we talked about this before. When you make a decision, now you can think about any of those. You can think about washer, or you can think about shell, but please don't make like 100% preference. Like, I'm only doing shell, that's it. Or I'm only doing washer. It's all about the function. But overall, if you decided, okay, this is dx, then look at the function. If function looks good to you, right? You don't have to change anything. If it's dy, then do you really want to change this for x equals, right? If it's possible or not possible. So those things we have to look at. All right? So any questions? So that's one kind of type of problem that you have. Now another problem with the volume still has the same idea, but this time I would like you to actually use your calculator to solve this problem. So let's take a look at number 2. So we have this function, y equals x squared. Then we have x squared plus y squared equals 1. The way I copied this, it says y is greater than or equal to 0. And we're going to write this about the x-axis. Okay? Well, if we want to sketch and see what we have here, well, obviously we have to take the second function, x squared plus y squared equals 1. And what's the equation? What's the idea? When you graph, what do you get?
A circle with the
Yeah, it will be a circle with the radius 1. Perfect. But if I want to graph it, I need to change this. So I'm going to put arrows. So I get y squared equals 1 minus x squared, right? And y will be what? Plus or minus, right? But now, if you look carefully, you see here it says what? Y is greater than or equal to 0. So that means what? I'm not going to use negative. Okay, so there's a limitation that already kind of pushing me not to use the negative y. Well, this is what we have. So let's just sketch and see what we'll get when we get to the calculator. So going back to this, deleting these graphs. So I have positive square root of 1 minus x squared. And the second one that I have, well, x squared. So let's graph and see what we have. Okay, so we have a tiny little thing here. Okay, we have a tiny little thing. Let me zoom in, see how that works. And I'm going to just go with zoom 2, just normal zoom. All right, so I see those two pieces, and remember we talked about enclosed area, right? So I'm putting this on the picture right here, and then from the picture we'll start talking about what Willie would like to do. Okay, so we have a parabola now. This is not exact graph, but we have something like this, and then we have the second piece. So that's the area that we're looking at. All right, so from here, remember we're going to rotate this about the x-axis. So here's the axis of rotation. So you get something like this right here, okay, sitting on the bottom. But remember, this is our main piece that we have to deal with. Okay? And the question. You're still making the decision right now to go with washer or to go with disc. What do you think? Well, washer or a shell, sorry.
Should it be shell?
Okay, well let's start with shell, and then we'll see if washer will work for us, okay? Because remember, we have examples, sometimes only one method will work. As we look at the previous example, I could do it with two different methods, so no problem. So let's take a look at the shell method. So if you go with shell, is it dx or dy? So that will be, with the shell method, right, it will be dy. And again, why we have dy? Because, as we said before, you're rotating parallel to x-axis. We're actually above x-axis, right? So for washer, it's dx. For shell as well, dy. Now, what that implies here right now, that every function that you have, right, every function that you have here must be solved for what? Must be solved for x, right? So let's take a look and see what we have. And also we have to be very careful because we need to know which one's positive, which one's negative. So if you look at the this one, again, y equals x squared, right? So when we solve this for x, we get what?
Y. Square root of that y.
Okay, plus or minus root of y. So the question is, do I need both of them? What do you think? And the answer is yes, because here's your positive square root. Okay, everybody, let's take a look. Here's your positive square root, and here's your negative. So we need both of them. Careful with this. And then I have to work with the other one. X squared plus y squared equals 1. I have to work with this one, right? And have to solve this for x again. So we have x squared equals 1 minus y squared. So x equals, we get plus or minus root of 1 minus y squared. Okay, so this is what we have here. And then we're going to see how we'll take care of this. But this is what we have. Now, here, the question still can be like, do I use both of them, or we'll use only one of them? Well, we're going to see what's going to happen, okay? It's not going to be pleasant, by the way. Not the best way to do it, but still doable. So don't forget, plus or minus what? It's our what? Semicircle, what kind of, right? But this will be positive, this will be what? Negative. Okay, so we still need halves. All right, so with the shell we have dy, right? So we're using this, just going to go back and tell you again one more time, and we're using this. And with the shell, my rectangle has to be what? Parallel to the axis of rotation, right? So tell me what's going to happen.
I have to do 2 integrals.
I have to use 2 integrals, okay? Because look, if you want to put parallel this, okay, so if you decided to put rectangle over here, then think about this. You're going to involve what? Positive square root of y and then what? Negative square root of y. But if you move higher, for example, put it over here, then you have to do what? This function, right? So for shell, we need 2 integrals. Okay? For shell, we need 2 integrals. So let's just set up, but the rest is just calculator work, okay? We're not going to do this manually. That's not going to be easy. This problem, like you had some on your homework assignment, where you have to use your calculator. So what do I need? Since I'm going with dy, I need what? Upper lower limit, right? I do have lower limit. It's my what? 0, right? And I need my upper limit. 1. So I need this one over here and see what that is. Okay? Do we get 1?
Yeah, it should be 1.
Okay, so, but keep in mind here, remember, what's going to happen? We just said before, because I don't want you just to forget. What did we say before? How many integrals do we have?
2.
We have 2 integrals, right? So that means you also need to know this point over here, where we're going to split this. Okay, I'm putting the line here, because we have 1 integral on the bottom, and then we have 2nd integral on the top. So again, you see it's getting more complicated here. So, this is right, it's 1, but what's over here? And that's where we need calculator, okay? You can't do this by hand. Not right, I should say calculator. We can, but not the best thing to do. So what do I need? I need to split this over here, right? So what do I need? I need y coordinate of the intersection. You understand that? Like if you look at my paper over here, I need, if I find these 2 points, then I know what y is. You understand? Because it's dy. So I'm going to go and find intersection. So second trace 5. And remember, you do that the same with the calculator, okay? And it doesn't make a difference which one I go. So here's your point, okay? And what we're going to do, we're going to round these points to 3 decimal places, okay? So this one will be, I'm writing the whole thing, 0.786 for x, and for y, I have 0.618. So what that means, I have my volume. The first integral, let's go, well, it doesn't make a difference. Let's start from 0. 0 to 0.618. So that's the area of the plummet area, but the volume of the bottom piece. So 2 pi. The next question, what will be the distance? Remember, you were rotating about this x-axis. You see how getting this complicated?
It'd just be y.
It will be just y, right? Because you didn't move axis of rotation. So from here to here will be just y. You understand? Okay, so you get y. And then what do we have? What will be the height of this rectangle? And we go from left to right. So what do we have? We have square root of y minus what? Negative square root of y. So this is the integral just for the bottom piece. Okay? Then plus integral from 0.618 to 1. Okay, let me move this up. And now I will move my rectangle higher. So my rectangle will be now over here. But still, the distance from my origin to this rectangle, it's also y. Okay, because it's just distance. I just moved it because I'm dealing with the same. There will be no 1 plus and all this. This is just will be y. So 2 pi y. Again, it just moved up. The distance from the origin to the rectangle is still y. But now what do I have? I have positive square root of what? 1 minus y squared, and I have to subtract. Now again, when I said positive, I'm talking about this one, okay? This little piece right here to the right. This is what I'm talking about. And then I will subtract the left side. And the left side is negative, the same thing. Well, and that's the setup for shell math. All right, not the very simple integral to look at, and the good news, I am not going to use antiderivative here. I'm going to just find each integral with the calculator. Okay, you understand? So if I go with the calculator, now don't be afraid that you see y here. When you put this into calculator, just change what?
Y to x.
Y to x. The picture will be different, don't panic. It's just the what's inside, right? That's the area, what's going to happen. Now, we can make it smaller a tiny bit. Because 2 pi y, and what do we get here? 2 square root. And please don't simplify. I'm making this just smaller because I have to put this into calculator, okay? But overall, I don't want you to move this to outside. That's just irrelevant right now. And then we're going to have plus integral from 1, not 1, but 0.618 to 1. Again, 2 pi y. And again, we have 2 square roots of 1 minus y squared. And dy. Okay? And we can just leave it like this, just waiting for the answer. So I put approximately. So now I'm working with just first integral, okay? Only the first one. So I'll go back to my calculator quickly. Just want to make sure we'll do a little more problems with this. So here, when I put this in, don't forget, when you're using calculator, like I'm not asking you to find antiderivative. I'm just saying use your calculator. And you should know what I'm asking you from your homework assignment because you had problems like this. Don't forget to put 2y. Do you understand that? Don't leave it alone because you'll get the wrong answer. So when I'm putting this into calculator, okay, I can put 4, for example. It doesn't make a difference. So I get 4 pi. And then I will have, you don't have to multiply. You can do x and then what? Square root of x. Again, remember, I don't have y here, but this is what I have. Okay, and then you go to graph. I'm going to do zoom 6 quickly. Okay, well, this is what I have. It's kind of stretchy, but that's fine. So I'm going to zoom in. We'll get this function. And what do I have to do? I have to find the area under this curve. Now remember, the question was about volume. But now I'm studying just the integral, right? And our calculator only knows area under the curve. So that's why I say find the area. Because I'm looking at the integral. But as the original question was, find the volume. So we talk about the same value, but not as a concept. So 7, and I go from 0 to 0.618. So when I calculate this, I'll get this number. Now, I would like you to, I'm just saying this is what you get, but if I have to round this at the end, I probably will copy this entire piece on the paper, not just rounding right now. I will round the very final answer, okay? Plus, and now we'll move quickly to this one and get the area again. So I'll delete this one and put that one. So again I have 4, again I have pi, and then what do we have? Y, which is x, and then square root of 1 minus x squared. I think that's enough, right? Alright, let's see what we can always catch this. Alright, so this one, I don't see exactly what I'm getting, so I'm going to go to 6, zoom 6, just to see how that will be stretched. Okay, so that little piece over here. So let me do this. I'm going to do zoom box. But what I will be calculating, I'm going to go for, well, let's involve this one. So, the very small area here, but I'm just going to go up, and this is what I have. Okay, kind of a little hook here, and then we'll go with the second trace 7, and I go from 0.618 to what? To 1, right? And I will get plus 2.035463, and when I do this in round, I get 35446. So this will be the final answer. All right. So what I'm saying here, don't use shell. Okay? Don't do it. Can be done. Not a very good idea. Better just to go to washer. So let's quickly jump to washer here. Did we do washer? We didn't, right? No, we didn't do washer. So if we go to washer method, for washer we'll get dx. Now, even for washer, I still have to change my function, right? Because one of them says y equals x squared. I like that one. But the other one is x squared plus y squared equals 1. Not the best one that I want to work with. So I'm going to solve this for y. So I have y equals plus or minus root of 1 minus x squared. But if you put back the picture, again, I'm just sketching this. If you put back the picture, what I really need, I need only the positive square root. Okay, do you understand that? Because positive square root will be just the top piece right here, the entire top piece. So hopefully algebra is okay here as graphs, okay? So that's why I need only positive. I'm not going to use negative. And you can put this into calculator, you're going to see what we have. All right, so if I go with the washer, I need to create this A of x, right? I'm going to create this A of x. And washer dx, again, we're rotating this about x-axis. So moving this around, and we'll get again something like this. Again, this is just a sketch. But then we have to do the cross section, don't forget, right? Something like this, so you'll get this one. Wash, right?
It's going to be a very, very weird looking solid.
Hmm?
It's going to be a very weird looking thing.
Yeah, well, I mean, that's what we have. So, again, the same story. We have to get the right radius. So the question is, what's the distance from x-axis, which is our axis of rotation, to this one? This will be what?
1 minus x squared, or pi times.
So pi times, right, if you put this in. And what will be the radius? What's the distance from here to here?
The square root of 1 minus x squared.
Right, it will be just the square root, right? Just a function. Our axis of rotation didn't shift, so that's a good news. You go from here to right here, it's just directly to the function, right? So we have 1 minus x squared and squared. So that's the area of the large circle, the entire piece. Then we're going to subtract, in the next question, what is the radius from axis of rotation to the bottom curve?
X squared.
It will be just x squared. So x squared squared. Well, and that's what we have for this one. So what do we see? No what? No two integrals, right? There's only one integral here. So if you put this into the volume, we can pull out pi like we normally do for this method. And then here you have, do you want to open parentheses right now, or? Let's just leave it like you know what we have right here. We should make sure we know this. So this will be squared minus x squared dx. So the question is from what to what? Well, we need to know x coordinates right here, right? Yes, no? Because it's dx, again, x-axis. So I'm going to go back to what I purposely kept, because I knew we need this. So one will be positive, the other one will be what? Negative, right? So here we have for x, negative 0.786, and here we have positive 0.786. So the integral will be from negative 0.786 and to positive 0.786. Well, that's what you have. That's your integral, right? So you can do the same thing with here with the graphic. But also remember I told you we really do not need to see the graph, because what I really like to see just like the number, right? So we can actually go to the function. Remember I told you there's a math. Go down to number 9. That's the function. I have this, the whole thing. Most of you have better looking integral than this. So I put my function here. So my function, well, probably I should square this, right? Right now. So I will have my function 1 minus, right? X what? Squared, good. And then minus what?
X to the 4th.
X to the 4th, right. So just easier, but you don't have to if you, oops, I should close the parentheses. Then comma, I'm going to use X as the variable, well, that's all my choice basically. And then we'll have what? From negative 0.786 to 0.786, close this. And then hit enter, and did we get the same? No,
Multiply by pi.
good. I forgot pi, that's a very important thing. So I have to go back to the function. I have
Just
to
multiply it all by pi.
I can do it because I want to go back, but you're absolutely right. So let me just get rid of this. So I'm going to hit what? Times by pi. All right. So did we get the same?
Yes.
Yes. So approximately will be 3.5446. We round to 4 here. So the question kind of split. First, we set up and round up our upper and lower limit to the 3 decimal places, but the final answer to the 4 decimal places. All right. Well, I don't know what else I can do about volumes, okay? I cannot sing, I cannot dance, so I don't know, but that's what we have, right? With the volumes, okay? That's all we have with the volumes. So we still have a couple of minutes. So now let's go to 2. Maybe integrals. Well, actually, you know what? Let's do this. Let's find area. Something still with chapter 6, okay? So this will be, what is this? Number 2 or number 3? Or number, what is that? 3. Okay. So let's take a look at the area. Okay. So here, again, going back to volumes for a second. With the volumes, you really don't have that big, you don't have a choice. It's not a preference if you like dx or dy. Everything will be determined by rotation, right? If it's dx or dy, but also the method specifically. But when we go to the area, so I'll put like area, okay, that you know we're looking for the area. And so we're looking for the area. Here, you have a choice. You can say you want to go with dx, or you want to go with dy. It all depends if you will get 2 integrals or 1. So area, more flexible. Okay? Area is more flexible. So when we put this into graphing calculator, and let's see what we get when we graph this, we have e to x. That's right above ln button. And here we have x squared minus 1. So when I graph, I will see if that will be enough. I think this will be enough. No, that's not enough. So I need to zoom out. So zoom 6, put it back. Okay, so that's e to x, and that's what we have for the parabola. But don't forget also, what else do we have?
-1.
We have x equals -1 and x equals what? 1, right? Okay? So I'm going to zoom. I really want to see what I have because I see kind of little thing here on the calculator that I don't like. But so I'm going to go further like this just to see if my left side intersects on x-axis. And I'm really saying no. So that's this piece. And down. Okay, so you see only parabola intersects at -1. Can you see that? But not the e to x. So my picture, a little bit, well, I should say complicated, but not perfectly both of them intersect at -1. So with the parabola, okay, let's say this is -1. Parabola will intersect here, but my e to x a little bit higher. And the same thing with this one. This one will be over here, so we have something like this. And then parabola will be like this. So my picture looks like this. Do you understand? So I'm looking for this area. So now I have a question to all of you. Would you go with dx or you go with dy?
Dx.
Dx will be very easy because what do you do? The top function minus what? The bottom. And you will have only what? One integral. Do you understand? But if you decided to go with dy, this picture moves this way. And then you have to split this, right? And here, actually, you will not have only two integrals. You actually will have how many? Three integrals. Okay? So, look, one more time. If you go with dy, this will be the first integral, this piece. Then this piece will be the second integral. And over here, you'll get what? The third. Not a good idea. So, quickly, going with dx. So, area integral. From what to what? -1 to 1. The top one is what? E to x. And then we're going to subtract x squared minus 1. I will drop the parentheses. So this will be minus x squared plus 1, right? dx. You see how simple that goes comparing with dy. So I have a flexibility here. So now going with antiderivative. So e to x is just e to x, right? I'm not going to panic here. This one's easy. Minus x cubed over 3 plus x squared over, nope, just x. I don't know why I'm doing this thing. Plus x, right? And then we go from -1 to 1. So e minus 1 over 3 plus 1. So that will be the first substitution. Minus e to -1 plus 1 over 3, yes, no? Plus, and minus what? 1. So this is what we have. Now, this can be a little bit more complicated than we think right here.
It should be plus
So
1.
let's see what we have. So,
Never mind.
So I just substitute again. I don't know if you have any question, maybe you figure this out, but that's what we have. So we have E, then what do we get here? Minus plus 2/3 minus 1 over E, I'll put it this way. Then what do we get here? So this will be -2/3, right? So we'll get plus 2/3, good. So I can write it like this, E minus 1 over E and plus 4/3. If you want to put LCD, that's fine, but not the decimal. Okay? So, like I said, for the areas between the curves, you can be flexible. You have to analyze, like, do I want to go this way or I want to go the other way? Now, the other problem may be, just to add to this, if you change this to, if you decided to go with dy, this has to be changed, so you get what, natural log y, right? And if you go with this one, then you will get what? Square root.
Of 1 minus 1.
Right, so then you can putting yourself into the substitution process, okay? So there are many things that we should look. So it's not kind of blindly doing something. We want to make this simple, easy, and not too painful. So don't forget that. So I guess we're going to stop right now, so please be here tomorrow. I will put more examples, and I'll do as many as I can. Speaking about what's left. Integrals, right? Definite, indefinite. Also, some things like approximating the areas with rectangles and working with the limit of a Riemann sum. So those things will refresh tomorrow. But again, work, practice. Need more examples? I think I mentioned this to you. I have a big assignment just for the reference online on Canvas. So you can just look into some problems if you want. But that one's not for the brain. And the other thing is, well, I don't know, just find all your old tests, number 1, 2, and 3, that you know that you have them, because final review will be over your exams. So, well, have a good day, the rest of the day. I'll see you tomorrow.
Good afternoon, Joe.
Don't take it with you.
Any first trimester classes, any two lessons, grammar classes, if you have a project for first trimester in Mr. Barrett's classroom, you have until Wednesday after school to pick it up.
It's
Each code takes